This is Grade 6 Math, Chapter 1.3, Common Factors and Multiples, Part 2. In yesterday's lesson, we worked on finding greatest common factors. Today, we'll work on finding common multiples of two whole numbers. Let's begin with this example. We're going to find the common multiples of 8 and 12. So, what is a multiple? A multiple of any given number is the product of that number times another number. For example, a multiple of 8 could be 8 times 1 equals 8, or 8 times 2 equals 16. To find the common multiples of 8 and 12, let's first find the first 10 multiples of 8 and the first 10 multiples of 12. So we find the multiples of 8 and 12 as follows. We simply take 8 times 1 to get 8, 8 times 2 for 16, 8 times 3, 24, 8 times 4, 32, 8 times 5, 40, and so on. Notice that each product simply goes up by 8. So 8 plus 8 is 16, 16 plus 8 is 24, and so on. Now let's move to 12. 1 times 12 is 12, 2 times 12 is 24, 3 times 12 is 36, 4 times 12 is 48, and so on until we've filled out the rest of our multiples for 12. Now that we have the first 9 multiples of 8 and the first 9 multiples of 12, let's look for common multiples. Well, both 8 and 12 have a multiple that's 24. Both 8 and 12 have a multiple that is 48. And both 8 and 12 have a multiple that is 72. So our common multiples are 24, 48, and 72. Let's try another problem. This problem asks us to find the first 3 common multiples of 3 and 5. So we'll begin by finding the multiples of 3. They would be 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. That's our first 10. Let's stop there. Now let's find multiples of 5. They would be 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50 would be our first 10. So the question is simply asking us to find the first 3 common multiples. So let's begin looking for our common multiples. 15 and 15 are common to each list. 30 and 30 are common to each list. And it looks like I didn't go far enough to find the first 3. So let's go back and add more multiples under 3. 33, 36, 39, 42, 45. Up, 45. I recognize that. 45 is a multiple of 5. It's also a multiple of 3. So here are our first 3 common multiples. They are 15, 30, and 45. Now try 2 of these on your own. Find the first 10 multiples of each pair of numbers. Then find the common multiples among those first 10 multiples. Please record your answers in your homework notebook. Let's move on to the final concept of this chapter, which is finding the least common multiple of two whole numbers. Our textbook teaches us 3 different methods for finding the least common multiple of two whole numbers. Let's start with method 1. In method 1, we simply list all of the multiples of each number. We're going to find the least common multiple of 6 and 9. And we'll begin by simply listing the multiples. Hold on just a moment, I'm going to list the first 10 for you. Here are the first 10 multiples of both 6 and 9. Now that we've written these, let's go through and identify the common multiples. Both 6 and 9 have 18. Both 6 and 9 have 36. And both 6 and 9 have 54. To identify the least common multiple, all we're doing is looking for the multiple with the lowest value. In this case, that's 18. So using method 1, we've determined that the least common multiple of 6 and 9 is 18. Let's take a look at method 2. In method 2, we're going to use, you guessed it, prime factorization to determine the least common multiple. We'll begin by writing 6 and 9 as products of their prime factors. So 6 would equal 2 times 3, and 9 would equal 3 times 3. In order to determine the least common multiple, we need to figure out what the smallest product would be that would contain both 2 times 3 and 3 times 3. Okay, so to do this and find the smallest number, this is the technique that I like to use. First, let's rewrite these number statements so that the identical digits are stacked on top of one another. That lets us see where there's duplication. So we can see here that each equation has a 3. We don't want to use that 3 twice, or we're not going to get our least common multiple. So now what we'll do is we'll kind of squish these equations together. To find the least common multiple, we're going to take 2 times 3 times 3. Do you see what I did there? I brought the 2 down, or the 3 up, however you want to think about it. Squish these 2 3's into one 3, and let's see what our answer is. 2 times 3 is 6, times 3 is 18. 18 is our least common multiple when we use our prime factors to calculate. Now let's try method 3. Method 3 calculates the least common multiple by once again using prime factors. Method 3 uses that bookshelf method that I like so much to help us determine the least common multiple. So what is our least common prime factor of 6 and 9? It's 3. 3 goes into 6 twice, 3 goes into 9 3 times, and 2 and 3 don't share any factors other than 1, so we're done here. Now, to figure out the least common multiple, all we do is take each of these numbers and multiply them together. So 3 times 2 times 3 gives us 3 times 2 is 6, 6 times 3 is 18. For finding least common multiples, this is likely my favorite method, simply because it's so simple and so elegant. If you understand how this bookshelf mechanism works, it makes these problems really easy. You don't have to worry about finding the duplicates like you did in method 2, and it's much faster than method 1. However, even though this is my favorite, it may not be the one that works best for your brain. So please use the method that helps you complete these problems in the most efficient and accurate way for your math thinking. Let's try another example working through all 3 methods. Let's find the least common multiple of 8 and 10. We'll begin with method 1, in which we simply list all of the multiples and identify which is the least multiple. So let's list multiples of 8. 8, 16, 24, 32, 40, 48, 56, 64, 72, and 80. Okay, now let's list the multiples of 10. This should be pretty straightforward, right? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. All right, let's go hunting for common factors, or common multiples, excuse me. 40 and 80 are the 2 that I see right away. Which is our least common multiple? 40. Method 1, done. Let's try method 2. In method 2, we use prime factorization. So we begin by writing each number as a product of its prime factors. If you need to factor it first so that you can see what the prime factors are, go ahead and do that. I'm going to do that now, just so that you can be reminded of the method. All right, so 8 as a product of its prime factors would be 8 times 2 times 2. 10 would be 2 times 2 times 5. Okay, let me find us a little bit more space to work here, and then let's complete method 2. So to complete method 2, remember we're looking for overlap in our multiples because we want to get rid of those, otherwise they're going to make our number too large. So let's write this as 8 equals 2 times 2 times 2, and stack it up with 10 equals being equal to 2 times 2 times 5. Remember here we're looking for duplication so that we only multiply by a number once if it appears in the other number's prime factorization. So 8 has 3 2's, 1, 2, 3. 10 has 2 2's and a 5. So these 2 2's and these 2 2's will treat as a single 2 in our final problem. We're removing any duplication. Okay, let me find us a little bit more space again, and let's finish this problem. So our prime factorization method becomes this. 2 times, remember we combined these 2 2's into 1 2, times 2. These 2 2's also became a single 2, and now we bring down our 5. So we find our least common multiple by taking 2 times 2 to get 4, times 2 to get 8, times 5 to get 40. Same answer as method 1. A little bit longer and more complicated, but a different way of thinking about it. So you use whichever way works best for your brain. Now let's try method 3, my favorite method, because I personally find it the easiest for the way I think about math. Let's try it together. Let's finish out today's lesson with these 4 guided practice problems. Find the least common multiple of each pair of numbers. Please record your answer in your homework notebook. I do not mind which method you choose to use, method 1, 2, or 3, as long as you show me all of your work so I understand your thinking and can help you identify any areas you're making mistakes if you're not getting correct answers. Have a great night. I'll see you tomorrow for more common multiples.